Looks like I'm getting better throughput this time. Not as much loss. And it looks like I'm online. It didn't update my title. What the heck? How's this look? I'm getting a lot of ringing in my headphones. I don't know if it's me or if it's actually coming through. Okay. I'm not going to bring up my actual stream. I just wanted to see the title. That was right. All right. So I'm a beginner when it comes to sockets, so I thought let's do some socket programming for beginners. And since I'm a beginner, I just take you on my journey. Okay, so let's go ahead and get started here. I've got some space down here for chat if any messages come in. Don't know if they will or not, but that's okay. I'm going to turn my volume down a little bit in my headphones. Hopefully its volume levels are good. I've got music going if you can hear it or can't hear it. I apologize either way. Rearrange some things here. Okay. So where we're at, I got this this folder set up. So I'm using Windows, but I'm programming in Linux using the WLS, Windows Subsystem for WSL, Windows Subsystem for Linux. That way I can create C programs like this, and I can execute them like that. Okay. So now that that's running, that's there. Create a new file. We'll call this socket.c. Okay. And I'm just going to go through this and kind of work my way through it and come up with my own questions and things. Now, anyone watching this, just know I don't copy and paste as much as I can help it. I try to I tried to actually type the things out so that it's not going to be so that I get the muscle memory and I get, how this is working and how it's put together, which sometimes means I'll get typos. So so I'm going to work through this. For anyone who doesn't know, sockets, they are what establishes connections between computers through the internet. So we're going to start here. There's just some information about sockets and what they are, as well as the compiler. Not going to worry about any of that for right now. And I've already actually gone through some of this to do a little bit of testing. So I kind of understand a little bit here. So what we're going to do here is, and this is what I tested to make sure that this stuff actually works. So we're going to include the socket library. That's part of Linux. We're going to create our main function. And something interesting about Visual Studio Code, it actually will automatically, it's giving me the red squigglies to let me know that, hey, there were problems as I was typing. The other thing is that some of these things like this, it will do some intelligent moving around. If I put, these in the wrong place or, mistake where I've got things, they'll move them around for me. I kind of I'm okay with pointers. I'm not very good with them. And so sometimes I can use all the help I can get. So we're going to initialize this here, the socket, I guess it means socket description. That's going to be the pointer, or not the pointer, the reference to the socket. And then these are some built-in types. AF iNet. You can choose iNet 6. This is going to work over IPv4. iNet 6 will work over IPv6, which I'm not using except for automatically configured things, and I don't. It hasn't come up yet for me. I haven't needed to use it yet. So, and then we're going to do a sock stream. Okay, so this function creates a new socket of type, and the type is the socket stream. In the domain, in this case IPv4, using the protocol, if you set a protocol. If it's 0, it's chosen automatically. So there we go. So if we get a -1, that means there was a problem. I always spell it soccer. Okay. So I'm going to run, well, first off, I'm going to build this. Run the build. Build successfully. And then I will debug this. Do I have, yeah, debugging is set up. Okay. So right now, it's initialized to 0. That's just what it's going to be initialized to at this point. And then those are the arguments. I'm going to step over this to see what we get back. So, okay, so we got back a 3. I'm not sure exactly what the numbers indicate, but you use that, I guess, as an identifier to go forward. So this means that it'll skip over that. So that worked. All right. So that means we're able to successfully build and link everything up that needs to be used to be able to create sockets. So that's good. Okay, and here's the description: the address family. That's what the AF in front of INET. This IP version 4. This was before IPv6, so it was just INET. They had to change it to be 6 later. And this is a connection-oriented TCP protocol. So now this is kind of cool. We'll actually use that socket that we created to connect to a server and get some information back. So this is using this struct, which is actually built in. So let's see. Yeah, so this is a built-in struct. We don't have to actually to create this in this way. This gives us information. The family, which is that INET, INET 6, things like that. The port number, the address. Let's see. Okay, and we'll get to that a little bit later here. And then that's a struct in itself. And then a 0. Yeah, so we need to actually fill in the address using this function, INET pton. Well, hello there. So, I forgot I had this running. If you put an emote in the chat, it actually bounces around the screen with some trailing things. So, welcome in, Dark Wiz. I apologize if this is boring. I am learning sockets, so I figured I'll go through it and learn it live. So, okay, so we're going to use that function to create an address, or to get an address that will be in this structure. We'll then set that there. Okay, so, and this is what we use to actually get that address. Now, that is, I don't trust the address that they're giving me, so I'm going to actually ping google.com, and I'm going to take this address instead. And just for now, let's copy that in there. All right. Okay. So we need to actually call this function, set the address, and then try to connect to it. So that function, the INET address function, is actually in that library. And I don't know, but I know ARPANET is one of the precursors to the internet, so I wonder if that's what this is a reference to. Okay, so we're going to create a new variable, and this is that struct that sock address in struct that we saw above there. And this should give us a, let's go to the definition. Okay, yeah. So you can see this sock address in, it's slightly different. So SYN port is another structure of its own. So It doesn't correlate 1-to-1, but that's not going to be a problem. Comment that out because that's going to be an error otherwise. Okay, we've got all the code that we use to create the socket. So let's go ahead and use that newly created structure that we just declared. I'm late reading chat. Sorry about that. Yeah, I work in Windows, so it's kind of funny. I'm programming in Linux, but I'm using Windows to do it, and it's just because my work is in Windows, and everything is there. Linux has a lot of really cool stuff that you can do in it, but you got to be really nerdy to really want to get into that level of it. All right, so we're going to set the address using that inet address, and then this is where this is going to come in. And later on, I'm actually going to I'm going to request a DNS lookup of the URLs to be able to get that address without having to go ping it and then get it myself and everything. All right. And then the family, this is the same as we set before, or AF inet. And then the port. Now, I'm not familiar with this function. Let's see what this function does. Oh. Okay, host short. Okay, so this is just a conversion program, or a conversion function. All it does is convert this into. Okay, it converts it into the format that we need, which in this case is, where did it see that? To an unsigned short. Okay. Cool little helper function. That actually comes into play later. We're going to need to be able to reverse, find the port number that we're connected to. We'll be able to pull it out using that. Okay, so we're going to go ahead and connect. If I could spell. And we're going to use that socket, and then we have to, okay, I see what we're doing. So this is going to, it's going to cast this memory address server to that structure type, sock address, sock ADDR. And that's just, we can go to the definition of that as well. And I believe we actually saw that up here. Yeah. So that's similar. Okay. Yep. So we're casting that. And then we're going to pass in the size. And check that it returns something. I've got my screen zoomed in to make it easier to see on stream, which makes it harder to program. This is actually going to be my second time playing around with sockets. I did this one time as a test just to see if I could, because I've had, as you know, sometimes libraries don't work right, especially in different systems. In this case, I wanted to make sure that it was gonna behave while I'm on stream here. I'm going to use printfs all over the place here. This code uses puts and things like that. I like printf because I like to every now and then add in extra stuff. Okay, so we're going to say error. Yeah. Otherwise, okay, so this is, instead of using else's or anything like that, we're just going to do that. Oh, yeah, good idea. I need to actually put new lines in the end. So I do Windows for work. I specifically work in Cold Fusion, so I do websites. I want to learn the ins and outs of low-level things, so I have a better idea of how things are put together and how they work. So that's the reason. That's the main reason. So all right, let's go ahead and build this. And I'd like to build some other things. Like I've built on the stream here, I built a Jeopardy game using Node.js and I think it's just mostly Node.js and then JavaScript libraries. But I like this low level stuff, this very, very low end stuff as well. So, okay, we have our server structure here. Yeah, exactly. I even do electronics, so I understand like literally the down low, adders and half adders and stuff like that, and transistors and how they work in order to know how these things really operate. Because you can say, oh yeah, a processor is made up of, millions of transistors, but if you don't know what a transistor does or how it operates, that basically means absolutely nothing. All right, so I've got my watches in. Oh, that's from a previous thing. Let me take that out. Okay. So we got our socket. Now we're setting. Okay, so that sets the SYN address and the. Okay. So that just converted into this. Let's see, the 0 is not zeroed, but we're not zeroing it out because we have no need to. Okay, that's set now, port 80. So I guess that's what that translates out to. Whatever that means. If I need to know it, I'll look at it later. And then we will connect. Let's see, when we connect, what happens? What does connect give us back? Oh, it's not going to show me because I'm in debug mode. Okay, we'll just run that. And it connected. So it successfully connected to Google. I will take its word for it because I don't have anything that's actually getting information back from Google yet. So that, I think that's going to be the next bit that happens. Oops, that's not what I wanted. There we go. Okay. So what does connect do? It opens a connection on the socket. Okay. Oh, hey, thanks for following. Hopefully, you'll be able to see the other stuff that I've done too, if you're looking for any other of the things that I've done. Like I said, the Jeopardy game that I made. It's Jeopardy in Twitch, so interactivity with Twitch chat. So it displays the question on screen, and then the you type what your guess is in chat, and it grades it using an algorithm to determine how close you are to the actual answer. It's kind of cool. That's one of those things I want to revisit, but it's kind of grown into a big beast, and I don't really want to revisit that. Kind of like the socket library that that was built. Okay, so it opens the connection. Okay, so that's all that does, is it just opens the connection for us. Okay, got it. Okay, so now what we need to do is we've established a connection. We need to actually send something to the server. In this case, we're going to send, I believe we want to send an HTTP request. Yep, exactly. Okay. So let's go ahead and include the string library. Is that all that we need as far as new? Yeah, okay. And we'll create our message, and that'll be a request. Okay. So, yep. We connect. Once connected, we will create a message, and this is just an HTTP GET request. So this literally is what every browser has to do as you're connecting to Google to get a page, or any page for that matter. Put in a couple of carriage returns. That's it. I guess that's the simplest we can get. Okay, so this is going to send n number of bytes to the buffer. Oh, no, bytes of the buffer. In this case, the buffer is going to be our message to the socket. And that's it. Cool. That couldn't be any easier. So we're going to send the... so the FD is the socket connection. The buffer is going to be our message. And the size is, this is what we needed the string library for, to be able to tell. We want no flags, and we want to make sure that it is not 0. Otherwise, we will print an error message. And we'll return that. Otherwise, we'll go ahead and print out that we sent a GET request. I keep forgetting those new lines. I think that's what the put S does, is it, it does all that stuff for you, so you don't have to worry about it. But I don't like mixing things up unless I have a good reason. Let's see. Oh yeah. All right. So let's execute this. So the build finished. Come on. There we go. Okay. You know what? Let's just run it. Okay. Connected. Sent a GET request. Cool. All right. So now, what do we do now that we've got a GET request? We have to listen for a receipt or for a reply. So a new char. Oh, okay. This is just going to be a buffer, an actual buffer. I guess so. We'll make it 2000. I don't know how large the message is going to be, so I believe there's going to be a way to tell it just how large the buffer is so it doesn't overflow it. Yeah. Okay. Yeah. So the receive. Okay. So that's easy. So then now we just receive. We give it the socket handle, the buffer we want, the buffer size. I'll hard code that for now. That's what they've got in the example there. Okay. Okay, yeah, so if it fails, yeah. Okay. Now, why is that not giving a... I'm going to add in the... Because we want to know that it failed. Alrighty. And then we will just print out the reply. Okay, well, that's pretty simple. Is the reply really just a... Oh, wait, no. Okay, this, yeah. Gotcha, okay. This function's cancellation point, therefore not marked with throw. Okay, I was wondering why we're not using any better error handling, but that's fine. Okay. So this should, in theory, spit out whatever, let's say in this case, Google responds back with, no, we call it a socket, didn't we? Hey, look at that. We got data back from Google. All right, so received a reply, and this is the reply. It's 200 okay. Nice, okay. So we just built the beginning of a web browser. All we have to do now is actually process the stuff that we got back. Yep, because here's the doc type and the HTML. Cool. So yeah, it only spits out, yeah. So the real question is how can we know how large that buffer is? So if we make that buffer, let's say, just a single bit longer there. Oh, that's interesting. We didn't get much more. Did we get anything more? I didn't build. Or did I? No, I did. Huh. Okay, well, I don't want that to be extravagantly large, so let's shrink that down. Yeah, that's interesting. Okay. So, all right, we're getting data back from Google. Nice. Now I'm curious if, I guess it came back with the 200 okay. But if you were to do like another address, like a one that redirects, I wonder what that would look like. Okay. How do you get... Well, we're doing... Okay, so... Yeah, 301. I'm trying to think of a site that would do a 301 redirect without spinning up my own. Because this is an HTTP request, and it should be redirecting me. It should be giving me a 301 because Google automatically does redirecting for HTTP S. Let's try. Let's curl. Do. Yeah, see, I should have got that. So why didn't I? How do I get the headers of a curl request? Header. Needs to go on the other side, doesn't it? No. What? Well, yeah, you use the IP, but it should... I'm sending an HTTP request, not an HTTPS request. You know what, let's see. HTTPS get request. So yeah, that's using. I want the raw, low down, dirty. How do you get it? Because I want to say you can't just put HTTPS because that will not work. I could be wrong though. Let's find out. Okay, I got a bad request. So, yeah, I'm not too worried about it right now. Because this, I mean, this is the same thing like if you do Telnet, Google.com, port 80, and then you do get. If you just basically type out that line, HTTP 1.1, and then you return twice. Yeah, see, that gave us the whole thing. Yeah, I think you're right that. Oh, no. I just realized it's the port number. I'm connecting on port 80, which is HTTP. HTTPS is 443. So let's see what happens. Yeah. Let's see. It didn't like that. I got back nothing. It's probably the wrong way to go about it. So, good to know. There we go. Okay, we're back to operating parity. I'll figure that out eventually. I don't think it's really going to matter. Yeah. No, see, what the heck? I guess it was all about the address that I hit. This one actually came back with the location where it moved to. Oh, that's interesting. This is google.co.in, so this must have been. Let's see what that IP address translates to. Oh, that IP address now is owned by somebody in the Netherlands. Oh, by Google. But it exists in the Netherlands. Interesting. Good to know. Yeah, see, I should, well, probably because let's do a curl on, let's do a curl on the IP address that I have. That's weird. Is the socket library automatically handling redirection? That shouldn't be the case. I mean, it's great if it does, I guess. These are all the questions that I am doing this for. To figure this kind of stuff out. Yeah, it's like it's redirecting me automatically to the end location. So then the real question is, in what I got back, does it give me the IP address? Because I'm connecting directly to an IP, but is it? No, there's no IP in here. Huh. Okay. Yeah, I'm not sure what all this junk is. This seems very odd, but not too worried about it. Okay, I will continue on. That's receiving the data. Cool. Oh yeah, my I haven't closed the socket. It's still open. Really? Close is just the... That's pretty easy. Wait a minute. Where's that defined? It's... Okay, yeah. Oh, okay. Need to include that. All right, now if I build it. Sometimes I don't get errors. Oh, hey, Willow. My daughter has joined the chat. You're gonna test the limits of my thing that bounces around the screen, aren't you? Okay, so close. That's it. That's all it does. That's interesting. Okay, so yeah, so we built that. Yep. Okay, cool. Do you guys hear the music that I have going? I'm kind of curious. So yeah, that's another thing I built is that bouncy thing. Okay, cool. Thanks. It has a limit. There you go. Yeah, so it has a limit, but you can put in so many emojis. It could be. It only works with the Twitch chat emojis. Are they called emojis? I don't know. Emotes. If you have something like Better TV or the what's the other one? One of the other ones. Those don't work, but things like so okay. So there's a limit to how many can be on the screen at once. There is a bug that Willow helped me discover, where if you put them all together in one message, you can overload how many is allowed. Because I think there's only 10 allowed at a time, or maybe 5 at a time. I tried to cut down on the amount that could be on the screen, but she discovered that if you put like 30 of them in a single message, it processes all of them. And I just haven't gone back and fixed that yet. Maybe I'll do that on another stream one day. So, okay. Cool. So we close the socket out now. All right. So, okay. Here's where things are going to get fun. Now, this is going to be a different file altogether. This is basically going to be kind of like a ping, but just getting the IP address of a host that you send in. So yeah, this is the struct that we're going to use. Okay, so I'm going to create a new file for this. Oops, wrong button. There we go. And we'll call this host lookup. Okay. Get rid of this. Okay. So we're going to include, obviously, standard library, so we get printf and stuff. Include string.h. Come on. Keyboard is wireless. Must be some kind of interference or something. I don't want to jinx it, but I'm having really good connectivity today. Maybe Cox is tired of hearing me complain, but my internet connection has not dropped out today, which normally it drops out multiple times a day. All right, so we've got the socket. We've got netdb, which gives us that hostint structure that we're going to have to use to get the host entity information. We'll go with that. I think that might be the actual reason for the name. I don't know. Oh. I heard barking. I thought it was... Like, that doesn't sound like my dog, but... it's in the music. Okay. So this is where I'm going to actually deviate a little bit. You know what? No, I'm going to do it like this, and then I'm going to change it. We're going to hard code the host name first, and then... Once we know it's working, I will program it to take command line arguments so we can basically recreate ping, like I said. The IP, this is going to be a buffer of 100 characters. Do we need 100? There's, let's see, 3, then the dot, then 3, then the, I'm terrible with math. Pull out the calculator here. 3 times 4. So that's 12. It doesn't matter. 100 is enough. Okay, all right, this is where I needed to do more research before. Okay, so yeah, this creates this structure, and then this one, oh, we had that one. No, we didn't have that one before. That one's different. But this is where I believe Visual Studio Code likes to add in that extra space for me for no good reason. Okay. Just to make sure that those are linked right. Yep. Okay. Build finished successfully. I just want to make sure that I didn't get any typos or anything in that. Okay. So yeah, we're going to create that one. Interesting. I mean, All right. And then this one is, okay. So yeah, does that match up? Wow, look at that. Pulled right from there. So hname, the official name of the host, alias list, host address type, length of the address, length of the address from the name server, or a list of the addresses from the name server. Oh, because we can get back more than one. Okay, okay, cool. Oh, that might be a thing when we look up Google. It might return more than one. Okay, so we're going to now do some things. So we're going to grab get host get host by name, and then that's going to take the host name. Yeah, that's it. Nope. Host name, and if it's okay, so if it's null, then we got an error there. Oh, I see what this is doing. This is herror. Herror prints to standard error output, which you can use. You can use different methods to pipe the output. If it's an error, it can go to, like, say, a separate log file than the output of the program, which would be more like for debugging and stuff like that. I'm not going to implement that right now. There is a way to do it. I think it's pprintf. Is that right? Where you specify where you want the output to go. In this case, it would be to H or to standard error. But we'll say okay, yeah, and this is the reason I like using printf, because I want to pass the host name to it so that the error, in this case the error message, prints out the error of who we are trying to get the host of. Otherwise, it will print out the success when we get to there. All right. And then we will populate the address list, which we created up here. Yeah. Okay. So the address list, we have to cast that. H address list. Yep. Okay. Okay, so we're the host int contains this. We're just pulling it out separately. I wonder why. I mean, you can do that. That's not a problem. It's not making any changes to it. And we're going to copy into the IP character array inet ntoa yeah, convert internet number in to ASCII representation. The return value is a pointer to an internal array containing the string. Okay, so that makes sense. So that's why we're copying it into an array. Because it just matches up. Okay, and then we just have to print it out. Okay, yep, the host name and then the IP. I'm assuming the IP is going to be a null terminated. Whoops, I don't need that. I've already got the return. It's going to be a null terminated string. Okay, so let's execute that one. No. There we go. Yep, and I forgot the new lines. Again. There we go. Cool. All right, so now what we're going to do, I'm actually going to, so I think, yeah, that's kind of the end of that one. And it goes on to a different one. What I'm going to do is I'm going to modify this because I'm probably going to use this again at some point. I'm going to modify it to take in an argument for the host name and spit out the information there. Now, first, okay, take a step back. So the first thing I'm going to do is check to see if the number of arguments given is, we'll say this only takes, this will only take 2 arguments. So if the arguments, say is not 2, we want to print the usage. So print F, we'll say usage and then like that. Return 1. So basically if you don't give it a command line argument, it won't run. So for example, by default, it's, and I forgot the new line again. Of course I did. Yeah. So if you don't give it anything, it'll do that. If you give it something else, it'll work. And if you give it 2 things, it doesn't like that either. So it only takes 1 argument. And the first argument is always going to be the command line, this. The second argument is always going to be this, and then anything else is going to be the next ones. So we just need to check to see that argument 2, or in this case, argument, the second argument is going to have to, yeah, resolve to Google. All right, so, okay, so that, and what this does is it short circuits it. It doesn't do anything else if I hit that. So now, do we just set the host name to, I mean, yeah, why not, right? Host name is Does that work? Let's find out. That seemed to work. Let's try a different site. Let's try yahoo.com. Hey, look at that. We built ping. Kind of. Yeah. Cool. It gives us the error message if it can't return anything. Let's see. DoD.org. Why not? That's got to be something, right? So, okay, let's debug and see what we get back. What form does all this take? So our host name, currently not set. IP, yep, once again, currently not set. Okay, so we're going to step over. Oh, I forgot about that. So if I'm debugging, yeah, if I'm debugging, it's going to, it's not going to send it any command line arguments. So let's do, where is my, here we go. Look at the configuration here, and we'll just add an argument. I believe it goes in here. We'll say that. So now if I run it, does it set the host name? No, it didn't. Where do you... I thought that's where arguments to the program went. Okay. Right, so this is to launch. The program is the file name without the extension. The arguments should be arguments. Here we go, command line arguments. No, because you're able to put in multiple. That's an array, so you can have multiple command line arguments, and they would be separated out by with a comma separated list, basically. Let's see. Okay. Yeah. Command line arguments passed to the program. Oh, wait a second. I think I know why. I had this problem when running this via the build as well. Let me try rebuilding, running again. There we go. Okay. Yeah, something. It's really weird. Visual Studio Code, because it's working with Linux through a client server setup to be able to do the debugging. Even building, sometimes you'll modify the JSON file that runs the build steps, and it won't take that modification for some reason until you relaunch Visual Studio Code. It's a small little aggravation that it's driven me up the wall, but that's fine. Okay, so the argument. So yeah, it's showing the path to the file. But where is... Oh, I see. We're not going to be able to see it because we're only able to see part of it. Where is my debug console? Let me expand this. Okay, yeah, it keeps my... Cool. So let me see if I can copy this value. There we go. That's not the memory I wanted. That's the memory I wanted. E5, B4. Okay, yeah. So let's look at 64 bytes of memory here. Yeah, so you can see this is the contents of memory. In this case, this memory location. So we can see these variables. Okay, that's my name. Slash Linux slash blah blah blah. Okay, yeah. So this is So this is why it's cut off here. It only shows in quotes there, it only shows the first argument. It doesn't show the second one because the first one is a null terminated string, and that's all that this knows to look at. It says, okay, I'm done reading memory because I reached the end. But what it doesn't know is that, no, it actually continues on and has more in it. So the second argument is passed in. I wish there was an easier way to look at this. There probably is, but I haven't. It's just not something I'm familiar with. Oh yeah, let me close that out. That was something from earlier that I didn't need open. Okay, all right. So that answered the question. Okay, it did get passed in, so that's good. So now let's run through this. It's going to set hostname to be google.com. Great. Everything else it's there, but it doesn't have anything in it yet. I is initialized to 0. We're going to step over that. And now HE has all the information in it. It has everything we need. So, okay, so HName, yep, contains google.com, which is what I believe we set that ourselves. But then you've got aliases. That's interesting. Okay, so there's nothing in aliases, but I guess if you have a host that has multiple aliases, then that would be an array, I guess. Okay. Address type, length, and then the address list. Okay, and this is where, yeah, so this is the address list, and it should be the same. Oh, no, we haven't set it yet. Okay. So now address list contains that, which I guess is the binary or the decimal representation of what we need to get out of it, which is the, oh yeah, that's what the inet into A converts for us. Okay. So most of the stuff is human. It's not readable, not human readable, which is fine because I don't need to read it. The name is about the only thing that is legible, and that's, I guess, why you have to call that. So then IP now. Oh yeah. So it goes through the address lists. There's only the one in there. And then now IP is set to 172.217.14.78, and then the rest is all nulls. And if we look at the output, the printf, is it terminal? Yeah, okay, it goes to the terminal. Okay, cool. Cool. Okay. Awesome. Yeah, so all that was, I mean, there was not a whole lot of human readable stuff in that, so debugging it didn't really help as much as I'd hoped it would. Let me now take that argument out because I don't need to debug it anymore. Rebuild, and I'm just gonna run it just to see. Yeah, see, it didn't update. It still took the thing I passed in to the command line, but that's fine. It doesn't really matter. Okay. Yeah, that was really simple. All that just to get. So the heavy lifting's being done by this library, the NetDB. That's, I believe, where the get host by name is coming from. Yeah, it's coming from there. So that's doing the heavy lifting of translating, basically getting reaching out to the DNS servers, getting a response back for that host, and then translating it to an IP. So that was super simple. So okay, so we could combine that with the socket here to get the IP address. Yeah, why not, right? So we'll change socket to take in a host name. And a port number. Yeah. That way we can play around with anything like that we really want to. So okay, so host lookup is going to put the IP address into that. So the real question is, how do we convert it into what this needs? And what is this one? This is an unsigned 32-bit integer and for internet number into ASCII representation. So we don't really want the ASCII representation, do we? Wait a minute. inet ADDR. Okay, let's think about this for a second. So if we get the host name, or sorry, if we take the host name and we put in oh, hi there. So do you think if I avoid C, C++, I'm a bad programmer? Absolutely not. Good and bad is relative. I used to think people that just copy and paste code from the internet and, stitch things together were bad programmers. At the end of the day, if you make something that works and it has a function, it has a use, then you're a good programmer. It may be ugly code, it may be buggy, you may have problems, but the more you make functional things, the better you get at making said functional things. So C and C++, it's very, very low level. It's also very old school in the fact that you don't need to know it for the most part anymore to be successful in any way. I am just a huge nerd, so I really like playing around with anything. I like to see what things do and how they work, and C and C++ is just another mountain to conquer. So if you have no urge or any need or want to learn C or C++, then by all means stay away from it. You're not missing out on much other than the in-jokes of people complaining about pointers and things like that. So, and it's really kind of a for me the imposter syndrome stopped the day that I realized that if I build something that ships, or if I build something that does something functional, it doesn't matter how good or bad that code is. It doesn't matter what it's built in or how you built it. It just matters that it's something that works. Yeah, see, and I actually know, I know few coders, but I could count on one hand how many C coders I know, and that's me. I'm the only one that I know that has touched C or C++, unless you want to talk about Arduino. That's a flavor of C. It's kind of toned down. You don't do a lot of things with pointers and strings and the like. There's a lot of functions built in to the Arduino IDE to make that as painless as possible. I like C and C++ because I'm a glutton for pain, as you can see here. Like, for example, this is the part that's going to kill me one day. My life is going to depend on converting data from one type to another. So where I'm at here, so this function takes a string. Strings don't exist in C, but it takes a character pointer and returns this structure, this host structure. I need to take that and get the IP address and pass it off to this, which is a different structure altogether. Wait. Is it? No, it's not. Okay. Whew. I dodged a bullet there. Great. So yeah, it returns that as okay. Yeah, so this is this is the part that is going to spin me in circles for hours, but I enjoy the challenge on this. So, okay, I'm going to recreate what I've got here. I'm going to take in the host name. I'm just straight up going to copy what I wrote earlier. Okay, so we've got a new so that's going to take the host name. We'll try to get the host before we do anything else. How's that? So we also need this. Or do we need that? That's the real question. So I would have to restructure that that file. That's a great question. So the way this works right now, the code execution comes in and it immediately just starts executing this main application. If I wanted to take this and move it into here by including it in some way, I would need to restructure this to do all of the lookup and things like that separately in its own function, and actually pull that out into its own file, and then from there import using header files and things like that. It's not something that I have much experience doing. I've done it a few times, but in this particular instance, it's such a short little thing that it's going to be way more work than it's worth to pull it out into its own, basically its own library. I may try doing that, but that'll be something. I'm gonna hit this one head on first, and then I like where you're going with that, though. Creating my own library to just handle getting the host name or the IP address via host name. But that would, like I said, it's creating my own library to do that, and I'm not there yet. I've done that. I've done it in the past. I just not today. All right. So this needs to be imported as well. Now the order that they have to be imported as well matters. So let's okay, it still builds fine. Okay, so in this case, we're getting the host name. Oh, we actually need to make this 3 because we need a port. And then the port will be down here. So in that case, we need to convert. We need to convert from a string to a number. Char pointer array to int. C. A to I. Is that right? Let's try it. Where'd it go? There it is. We'll do A to I. I wonder what we'll do 3. And what library is this one in? A2I, is it in math? I think it is. Come on. Keyboard's not working. Didn't like that. Oh, is it in the standard lib? I could probably put that one higher up. Hey, there we go. Let's test this one. I do need to actually change configuration, put arguments, google.com and 80. That should be fine. Okay. Not host lookup, sockets. All right. Let's see if it likes this. Yeah, it doesn't think I put any arguments in it yet. There we go. Okay. I guess I just had to drag that down. Okay, so let's go ahead. Host name now has google.com in it. We're going to step over that. HE is now set with data. So technically HE now, oh, okay, I'm getting ahead of myself. Created the socket. I'm using that address for now. and then server SYN port 63486, and it crashed. Or did it? Yeah, I think it may have crashed. Let me run it from the terminal. Oh yeah. Yes, segfault. It didn't like that. Why didn't it like that? Oh. Because that array value is out of bounds. There we go. And we'll test that. 443. Interesting. Okay. All right, so that worked. Surprisingly. Would help if I got my arguments correct, but yeah, whatever. Oh yeah, I'm curious now if I do it with google.com and then let's say words. It's going to convert that into a port number. So right now it's trying to connect to a port that it can't. I don't know what port it's trying to connect to though. Okay. Yeah. So it just says it can't connect. So I won't worry about that. Okay, cool. So we got, all right, so we got arguments now. So now we need to convert this. We need to set it there. So that is, so server is set up here, right? So can I just say, oh no, because it's going to, it returns that host DNT. And then I need to convert that. That's what this was doing down here. It converts it into an address list that it can then go through. But then that's just converted into that, which is what that is. So, can I just do this? Let me create a backup of that. That way I know what I changed it from. Yeah, I didn't like that. Well, it didn't error though. It just It didn't give me an error. It gave me a warning. Makes integer from pointer without a cast. Maybe if I don't put it that far. What doesn't make any sense is there is a cast. So server is that. Let's see. Wait a minute. Would that be that? No, it really doesn't like that. Error. Incompatible types. Let's try running it and see what we get. It's doing something. I don't know what it's trying to do, though. I wonder if it's trying to connect to another address or something. Let me just double check if I take that out and put that back. Oh, wait, I have to build. Okay. Just want to make sure. All right. So there's an address list though, and it's casting it to a pointer of that type. Let me go back up here. So the host ENT, yeah, it's got address lists. Okay, so the server is sock address in, so it's this, so server, and then the SYN address is an in address. See struct in address below. And that's just a it's just a unsigned long. So what is an address list? Let's see. So, okay. So the address list is an unsigned 32-bit. I, I think that's the same type. So it's just a number. It's just an unsigned long number. Oh, thank you. I'm behind on the chat, but yeah, if no valid conversion can be performed, it returns 0. So I need to check for 0 then. That's okay. We'll create under the host name, we'll do all right, so we'll get the port number, and if port equals 0, yeah, basically if the port 0, we'll print F. Here's what I'm going to do. of that, don't I? Let's try that. Okay, still with a warning. That's fine. All right. Okay. So that's set. Now what's it set to after this one? No. So that's... I need the... Okay. Yeah, it's not that. What I need is to get the first item inside of here. I don't think this is going to work, but I'm going to try it. Okay, that was a warning, but I might need to get it, set it to something, and then set it separately. Let me set a watch for this. So it's going to be server.syn addr saddr. Yeah, of course it's too big to fit. Okay, I don't care. I'll just... All right, so that's set. Nope. Wait a minute. Wait a minute. I just realized the IP address I'm getting and this IP address might be different. Because, yeah, I'm getting... Dang it. Yeah. So it might be setting it right, but I don't know. I don't know without doing the whole conversion that I'm doing here. Yeah, because this is an address list. Now I'm just going to copy this whole line. And let's do it that way. I'm going to get rid of this line. And where am I getting... Where am I getting HE from? Wait a minute. I'm not even setting that, am I? Oh, yeah, I am. Yeah, okay, here we go. So I'll do it here. My neighbors upstairs are being loud. All right. Let's put this here. Okay, it's able to build. So now I have address list. Okay, let's run again and see what address list gets set to. Take out that breakpoint. Where is it? There it is. So it's an array. So if I add this, F8, F8, okay, that gave me something. Negative 114. Oh wait, there's, well, I mean, is that what I'm looking for? One, two, three. That's 3 bytes. Okay, let me try this. Instead of that, I'm going to do that. Okay, give me a warning, but makes integer from pointer without a cast. Do I want? No. I mean, I want to cast it, don't I? Realize I'm debugging as I'm doing that. Assignment to in address T, aka unsigned int, from struct in address pointer. Makes integer from pointer without a cast. So I want to cast it then. I do that? That's not what I want. Yeah, let's run that. See what happens. Nope. No go. Do you mean with just setting it straight to address list? It gives me the same warning. Let's try that. Nope. No go. This is one of the things that drives me crazy about hard typed languages is that this is a crazy arbitrary like data structure type, and literally all it is a number. Like, why can't I just pass around the number? Why does it have to be this freaking complicated to work? Yeah, exactly. It's C. That's why. Wait a minute. That was it. That was it. I was pointing, excuse me, I was pointing to the structure itself. Yeah, I was pointing to the address list structure, to the first item in that array, but it was looking for the SADDR. So the way I did it, I could have done it that way, or I could have done it this way. I think I'll do it this way. Let me try that. Or not. Okay, cool. No worries. All right, so now with that, I can do Google.com on port 80. I could also do, let's say, Twitch.tv on port 80. That's interesting. Let's do yeah. Cool. So now I'm taking in a port number and the domain name. Sweet. Oh, good idea. Twitch on 443. Let's do that first. Oh, that's interesting. It's not doing anything. I think it's also because I sent this message, and I think if you're gonna request HTTPS, it needs to be something different. Let's try this. Oh wait, helps if I build. That's a 501, I think. No, 500. Domain not found. I'm curious if it has something to do with the .tv. Let's find out. Somebody else. I didn't want to search Twitch. Okay. Let's see. .tv domain. 500 error. Yeah, so the error codes are interesting. Oh, maybe you're right. So error codes, 400 means you messed up. 500 means I messed up in terms of like users and programmer logic. So if a 500 message, that's an error on the server. That means somebody programmed something wrong and it broke. That's a 500. It means I messed up, as in like I'm the programmer, I messed up. 400, you messed up. You typed the thing wrong. You tried to go somewhere you weren't supposed to be. You tried to go to a page that doesn't exist. That kind of thing. A 300 message means something's moved around. Let's get you to the right place. And the 200 is everything's fine. But yeah, you're probably right. There's probably something to do with a user agent, or some other type of header stuff that needs to be sent along with it. So let's see. Let's look up minimal HTTP requests. So yeah, this is what I did earlier, the telnet. You can do a get like that. Get gives you that. What? I wanted more information. That's all you got for me? Here's the status codes. Where is where's the teapot? $418. They don't have that listed. Lame. Okay. That's response headers. Okay, yeah. See, these are the responses. Ah, gotcha. Okay. That makes some sense. I should probably Oh yeah, let's see what so what you're saying you did so if we do host lookup twitch.tv and if we try to go to that IP address, let's say in a browser or something, directly. That seems weird. I wonder if curl will give us more information. Huh. I feel like that's information that shouldn't be visible to the end user. Almost like a debug message or something. Interesting. I'm not going to go down that route any further, though, because I don't know enough to not get myself in trouble. Right. Yeah. So it looks at the domain that you're coming across, not so much the domain that you're requesting. How would you specify that in a socket connection, though? Let's see. I guess I need to learn more about HTTP connections. So that's the other thing too. Is this is connecting through it's sending HTTP request. It could be any kind of server request. So, for example, I could try to connect to. Let's try an IRC. All these are assuming I'm wanting to do a. I want to use an app. Like, no, I want to make an app. EFNet. Let's try that. Oh, cool. I didn't know that you left. All right. I'm going to try this. Telnet IRC chupa.net. What port? Six 6665. I was thinking if we could connect directly to a server like an IRC server, and then figure out what commands to send it through something like Telnet, then we can programmatically do that with that socket application. This is not connecting though. Let's try the last port. Maybe my IP is. We'll try a closer one. This one's in LA. Okay, so that one didn't work. Okay. Cool. Interesting. So, I don't want to send it this. You know what? No. Let's send it that. So I will send socket irc.mzima.net 6665. Nice. It exited, but oh really? So all I have to do is set the host. Let's do that. So, colon and then I'm gonna hard code it for right now. All right. There we go. Yeah. So I got a 301 instead. Nice. Nice. Good call. Let's program that in. Let's add that in there. Oh man. I don't know how to concatenate strings in C. Let's find out. Wait, no, I can use a print F. Let's see. Oh, it was S printf. Let's see. Set message is a char string, right? Yes. Let's go here just to see. I want to swap. Okay. I mean, is that what I want to do? Copy the first string into the variable, concatenate that. Sure, why not? So Oh, I see. Okay. So I'll do that. And then str cat message. Wait. Want that. See if that works. Nope. Segmentation fault. Great. What did I do wrong? It has to be, in this case, it actually has to be an array. So we'll say message 500. Let's try that. Does that work? The error isn't clearing, but it successfully built, so bad request. Oh, I need a string copy. There we go. Okay. Yeah, I don't know what's going on with the syntax highlighting. I have a feeling it's Studio Code freaking out on me for no good reason. Let me reopen it. Yeah. Okay, there are no error squigglies though. Yeah, Studio Code is it's great when it works. And we will do, instead of a string here, this will be host. Host, is it host name? Yeah, host name. Will that work? Oh. There we go. Oh, I gotta build it. There we go. Ha, look at that. So now, no matter which host, oops, no matter which host, there we go. Now I'm getting a 301 from Google, which I would expect. Yeah, so that's exactly what I was missing. Okay, so I just needed to build up the build up my request. So just a simple GET request wasn't enough. It needed to have a host name in there as well. And then I can use this to then build a larger request of some kind going forward. Awesome. Cool. And then when it's done, it closes the socket out. That's cool. It's very cool. So yeah, Twitch takes me there to the move permanently. So, okay, yeah. So now it's trying to get me to go to HTTPS. And the Google one. Okay, so with Google, is it? Okay, interesting. So that's okay. So if I get a 301 response, I should follow it to where it goes. That's what most browsers tend to do. And you can turn on following or not. So twitch.tv is going to HTTPS. So can I do 443? Now I have a feeling that I'm getting something back, like something else is supposed to be happening that I'm not processing right, or I'm not handling right. I wonder if that has anything to do with like escape characters or something. I got a reply from Google and it was gibberish. So if we do google.com 443 on telnet, if we do get /HTTP, I didn't get to type it all out yet. Come on. It wasn't expecting a human to be doing it. Yeah, that's what I figured. It's probably going to be a little more complicated than that, than just connecting and working. But I would expect to get something back, some kind of information back. It might also just be that I need to handle it differently. So let's say my Google foo is a little. Yeah, you're right. But I wonder how you initialize the handshake. Hey, look at that. Somebody else had the almost exact same question as me. So let's see what the answer was. You're trying to talk to an HTTPS server. That requires you to establish an SSL TLS channel. That's really difficult to do on a plain socket. You'd have to implement the connection negotiation, the client-side validation of the keychain, and session encryption, decryption, and so on. A more sane way would be to use SSL socket. Oh. Talking to a socket is not a sensible approach. You're not really going to learn much by doing it because the normal way to talk to well, that's not a helpful answer. Basically, the answer is you're doing it wrong and you shouldn't be doing that anyway. That's just lame. Let's see, HTTPS socket C. Okay, yeah, somebody had the same thing, just in C. Okay, look, just like HTTP requests, but with transparent encryption of the actual communication between the client and the server, and on a different default port. The good news is that transparent encryption allows you to program just like you're writing a regular HTTP client. The bad news is that the encryption is complex enough that you need a specialized library to implement it for you. Okay, OpenSSL, that's fine, that's perfect. Used port 443 instead of 80, okay. Initialize OpenSSL, do this once and stash a global variable. And the only reason I'm really taking this any serious is because so much of the internet now is SSL. So okay. Create an SSL connection and attach it to the socket. I'm gonna try this real quick just to see if this still even works. Okay. Okay. Wow. Yeah, some straight up global variables. SSO. Load error strings. I don't know why. So this is to initialize it, but it's not actually. I don't understand. I don't understand what this is. Why does it have a space and why? That shouldn't even be a thing. If I put it down into the main function, does it build? Build finish with errors, no. Oh, wait a minute. Undefined reference. I probably need to link it. So let me move it back out here. Okay, yeah, this needs to go in main. And it, okay, so there's no errors there, but it's a linker error. So, not configuration. Terminal figure task. And this is where I have to link. I hate when Studio Code decides I'm going to put a whole bunch of stuff in here that you don't want or need. What is the... Will it tell me what I need to link it with? See, okay. Just LSSL? Let's see, did it add... G... Yeah, it didn't actually execute my thing. There we go. Cool. Okay. All right. So then we do SSL library in it. SSL CTX. B23 client method. All right, well, oops. Okay. Let's see. Create SSL connection attached to it. The socket. Okay, I'll do that. I want to move these actually. Down here. Oh, the... whole color coding has gone weird. Let me restart Studio Code and see if that helps. Dang it. All right, yeah, now my coloration is back. Cool. Cool. All right, so let's do our SSL connection. So SSL connection equals SSL new SSL CTX. So set FD oh, okay. Attach it to the socket that's already existing. Interesting. Okay. Perform the handshake with the server. And on the server side, this will use SSL accept. Okay. So, we'll say if SSL connect connection is not equal 1. Excuse me. Excuse me. Oh. Use SSL read and SSL write instead of all of that. So, oops. Just 1 second. Alrighty, I'm back. Hopefully my volume isn't too high or low. Yeah, so let's does it build? It builds. Does it run? That we shall see. I'm going to actually step through the code. What? Debug anyway. I already checked it. right? I built it though. The build finished successfully. Undefined reference. Because the stupid linker didn't link. Open configuration. Okay. Why are there two? There shouldn't be two. There should only be one. There we go. Step over that. Step over. Step over. Okay, that works. That works. SSL. CTX. Okay, that updated. I don't know what that means, but it updated. Okay, then we get the address. Step over that. Step over that. We got our socket. Now our connection is here. Now that has something in it. So now it connects. Okay, crashed. Let me run it again. Hit the wrong button. All right. I'm trying to see where it crashed. Okay. So now we're going to send the connection to SSL Connect. Let's step into it. It didn't crash because we didn't get a seg fault or anything like that. So I think it worked. And so now we use SSL read and SSL write. Cool. Okay. So let me do this. Port equals 443. We only want to do this in that case. So then yeah, I'll move this down. Oh, wait. Okay. So we'll take this and move it down here. And we'll put these up inside there. This up here. So only do this if it's port 443. And then the rest of it, let's see, did it say to so instead of doing connect, okay, yeah. So that's the actual connect. So I'll do I'll copy this. Question is, do you still need to do... No, you don't need to do that connect anymore. Yeah, because that handles the connection. Okay, yeah. So then... so I've already connected, so if I don't need to worry about this or this. I mean, okay. Yeah, I can move this up here. Oh yeah, I need it up there. Okay, so that's there, and then this is, so port is 443, do that, else do this stuff. Yep. Yep. Do that, and then do this, and then copy this. I think it means like do the connection that I'm doing here. Could be wrong though. Let's see this. Copy weird. And I know I'm kind of duplicating effort here, but I wanted to see if I can SSL underscore send. Yeah. Or SSL write. Yeah, that's it. Okay, so SSL write. So it takes in the SSL connection instead of the socket. Which is con, right? Yep. CONN for connection. Okay, it takes the SSL, the buffer, and a num, which too many arguments? All right, I'll take that out. I don't know what the number is. I think it's supposed to be the length. Go to definition. It doesn't say. And it doesn't say size or anything like that. It just says num, so. Okay. So SSL write and then SSL read instead of receive. I'll do the same thing here. If port equals 443, else do this. SSL read. Okay. I have a feeling it's the same thing. Yep. SSL, so this will be con, and then this will be con buffer, and then integer. That I'm just going to assume is the size. It doesn't say. Okay, and then do I need to close? that? Is that a thing? No, doesn't like that. Okay, well, it's fine. All right, let's try that out. First off, let me just do port 80 to make sure that's still working. Okay, and then we'll do 443. Okay, well, it didn't error. Okay, let's see where we're at. Okay. So we step over that, step over that. Got our address. We got our socket handle. Let's get our port number, 443. The port is 443. So we load all that stuff up and we set those. We connect. Unable to read. I get that. It must be crashing. Step out. Yeah, it's crashing on the connection. So what am I doing wrong? Do I need to connect first? I think I do. So let me do... Yeah, if I miss chat, the emoji thing really grabs my attention because I see motion over there and I'm like, wait, what was that? Okay, so let's move this outside of the port association. Because we want that. We want that to connect no matter what. And let's take out the else. Okay, let's try that. Will that build? Yes, okay. All right, let's set a breakpoint down at the connection. We'll run to there. Okay, we set it, and now connect. Hey, look at that. Look at that. Look at that. We have SSL now. Boom. Nice. And that was fairly pain-free. It was easier to do that than it was to do the host translation. That's cool. That's very cool. So yeah, that's all it took was adding in some checking for the port number and the SSL OpenSSL library. Cool. So yeah, it now connects, and just to double, triple check, let me go port 80 again. Yeah. Let's do Twitch. Moved permanently to www.twitch.tv. 200 reply. Nice. And there's the cookie. So okay, yeah. So the set cookie came back. It gives me an expiration for when that certificate expires. Awesome. That was a lot easier than I thought it was going to be. I thought adding SSL was going to be a huge burden, and like even this made it seem like, oh yeah, there's extra. Excuse me. There's extra steps. It's this and that. And no, not at all. It was quite easy actually. So sweet. Well, I think that's a good stopping point. I think I think I did a lot, and I was able to actually make some progress, learn a lot about sockets and everything in C. That's a fair amount of code written today too. So that's awesome. Yeah, Darkwiz, thanks for joining along and everything. You gave me some good tips there, and made me kind of learn something that I might not have done otherwise. So I really appreciate it. So thanks for hanging out. I'm gonna go eat some dinner because I had a long day of programming, and then I streamed programming for about 3 hours. But yeah, thanks for hanging out. Thanks for anyone who dropped in and dropped out, or anyone who might watch this later. I'll probably have this uploaded to my YouTube as well, which is just a place to hold this, since Twitch tends to delete the videos shortly after them being recorded. But yeah, cool. Thanks everyone, and I'll see you guys in the next one.